Hello, my name is Felix Schaller. I'm from the HUBCAP platform Validas AG. We as Validas AG, we are experts in functional safety and also model-based software development. I would like now to present you a tool that I am developing in cooperation with Validas AG together about a platform that is capable to process natural language documents like technical documents or any other documents that have a hierarchical chapter structure, like they are common in technical documents. This tool is capable to read these kind of documents on a text on an ASCII text basis. So you have to provide this tool the content of the document in an ASCII form, and then it will parse this document as a model. So first of all, a bit of the background. What is this natural language parsing tool all about? So it's as I mentioned, it's a platform for natural language processing. And the current status is that it is turning text into a model where there can be written natural language parser on top. Like you can use neural network parsers, and also what's the goal of this project? Model-based natural language. That means that we do not intend to create a trained neural network to interpret natural language, but a model that defines explicitly the meaning of the content by rules. So the idea is quite old. It's about 60 years old. It started in the 1950s and also was mainly rule-based, but they have the advantage disadvantage at this time that rule-based natural language was really hard to solve, because every function and every condition has to be handwritten. So in the newer ages, or in the last decades, that's why the statistical natural language processing, with the most popular approach with neural network, has gone popular. So because in this domain you can rely on machine learning that is acting in a way organically and is not requiring any programmatic design and any elaborated rule set that has been engineered in advance to know every condition. And this is something that is quite awkward, and also it's not so safe, because the designer often doesn't know the real conditions. And that's why the more organic way, with a neural network adapting itself with feedback loops and training feedbacks to the final result, these solutions are therefore much more efficient. But they have the disadvantages. One is that neural networks, they have they're just a matrix at the end that is not telling you the real reason why it found the solution. And second is that a neural network can just roughly guess the meaning of the content of this of the sentence, but do not design an explicit functional constraint or any syntactic, well, at the end, an explicit meaning out of that. Well, so to say, many scientists in this domain would say, yes, the language is ambiguous and therefore is not really capable to express itself explicitly. we contradict this this statement, and this tool also wants to prove that language has a really explicit nature, with the exception that you need a real, or you need a certain context for the language to really be able to be interpreted correctly. So there's always a context necessary, and also terms are not explicit defined, but they are more rather negotiated within the context itself. So the meaning, what is meant in the text about a certain term is evolved, or emerges out of the context itself. So it's a kind of emergent process that finally traces down any conditions of the meaning to the final claim. So the content is not partially expressed, but all conditions are argued completely. And that is achieved by defining the context, or to create a context that this natural language can formulate all the conditions that is required for the context. All right, that are just some kind of examples from what is used today, like some clusters in neural networks that define certain meanings of a certain term and how they correlate with each other. And the lower picture is an example of a toolchain that is processing natural language and finally solve the content. So far, what this NLX tool is capable at the moment, or this is our tool chain. Like first we want to solve the grammar with a DSL, we tokenize it in a model, and then we are building a syntax and morphology algorithms on top that are for us resolving grammar, and by that finally leading to an ontology, a relational ontology that defines the content of the documents itself. So it's also intended to cross-relate over several documents, and you can extend it eternally. So finally, it can a huge knowledge database across many documents, internet contents, and so on. And finally, in this ontology, all the meaning and the functional constraints are then laying inside. And then finally, you can create programs or any other execution processes out of it. So you can design processes based on natural language requirements, test strategies, and so on. So that's that. The use cases are huge, and therefore we would like to provide a platform that allows you to develop many different use cases on top of the platform we provide. All right, so this is the overview of the tool. I'm in a Windows domain, and I'll just show you in a few seconds the operation in the HUBCAP platform. So here we have the browser of the sources. Then here, this is our text editor where we can modify the document and adapt it if there's some parts not explicitly parsed because it's not a real language or has a certain odd format inside that is not following a classical technical document. This is more for development purposes, a property viewer where you can view the property of that model. So finally, when this document is getting passed, you receive a tree-like model, kind of directed acyclic graph that is resolving the content of that document in a tree like graph. This is something under development that is then will then finally resolve the semantics of the meaning of the content. So it's intended to that you be capable to train grammar on top of the tokens or the language that is parsed and finally based on certain word types like nouns, verbs, and so on, you will be able to develop a organically trained grammar. This is also seen as a hypothesis that you can do machine learning on models, and but it's still on development. So there comes another presentation for that in explaining this in more deeply and how it is working. So we are today we just consider on the working part of this program that are use cases that are already working, and this would be creating a model out of natural language documents, and it works like with Xtext. It's a framework for the Eclipse framework, and this is offering a antlers parser under the hood that turns DSL, in our case a natural language document, into a eco model. It's a kind of model from Eclipse modeling framework that is designed, or it's automatically designs a class diagram where it's generating code out of it, so you can create model object that then finally create a hierarchical tree model out of it. With this tree model, then you can do lots of things like any type of natural language processing. This presentation goes more deeply into the functionality of this parser. I won't not go too much into it because it's not the focus of our presentation. So I'm just showing you some slides and what is what is under the hood of this program. Right, let's start the program itself. So I already chosen a workspace with all the documents inside as a demonstration, and it will now open up the program. All right, you can see that in HUBCAP it looks like the same. It just have a little smaller screen, so it is everything a bit more condensed form. So when I just so this is a document that is showing how this is working, and now here in the outline you can see the model of this document. I created an introduction, so then you can walk through this model and see that this the root is the model itself. Then it It contains a paragraph block. This is a paragraph, and then inside this paragraph there's a sentence chain, and finally the sentence and sub-sentences. So here it's just one single word. That's why it's a bit hard to see. And now when I go into this sentence, you can see that I have here a sentence that is separated by a comma, and then so I have two sub-sentences. Sub-sentence 1, sub-sentence 2, and so on. So, and it also offers say content tables, chapters, and so on, paragraphs, list sentences with numbers, and also with bullet points, and then it has subchapters and so on. So, but it's just a little demonstrator. It gets more challenging or more exciting when we are opening real comprehensive documents, like for instance large standard industrial standard documents like we have here. So the ending is NLX, but actually it's just a standard source code document, ASCII document that is just standard ASCII text, usually with UTF-8 encoding. So here it's getting a bit more comprehensive, and you see that when you dig in this model, then you get kind of numbers and units and symbols, and so it is parsing all those things like in sentences and paragraphs. And further down we also have tables that are capable to be interpreted. Here's for instance, right. So this is then showing a table that can have table lines and so on. So it's also capable to interpret tables and content of the table. That's something worth a show. And then also, yeah, as you could see, list sentences with letters in front or bullet points. So you have then several list sentences, because there is a space, empty line in between. It's separated by paragraph blocks, but at the end all this is captured by the tool, and it also detects paragraphs that are having a leading chapter number as a chapter, as a headline, a chapter entry, and by that the generator is then interpreting this document as it should, with many chapters and subchapters. So when I've finished this editing this document, and then finally resolved all the errors, because when I am just do some stupid stuff like here, then you will see that the parser has an error, because it cannot really parse some certain special character that make no sense to him, and thus he cannot interpret whether is it a word or not. And therefore this would look like if I would not have a incorrect format, or when something in conversion, maybe I have a PDF as a source document, put it through a converter into text, and this text is not really probably solved or converted the PDF to the text, and then I have to do manual corrections to have a correct textual document that is following this document rules as a normal technical document should look like. Right, when I have everything all the errors are solved and just warnings that are, for instance, showing that that I have a capital letter in front of a starting sentence. Sometimes when it's a bracket sentence, it's not required, but usually when I have certain, it's mostly brackets here that are not starting with a capital letter. That's why I receive those warnings. All right. When I then save this document, the generator in the back, it creates a process modeling document file for the process modeling tool. So when I open up this process modeling tool, I will be able to read the generated content of those documents or of these models. I create XMI models out of it. They're common for the Eclipse modeling framework. And so demo project. So for instance, we have now this DO330, and when I save the document, the parser is creating such a model out of it. So with this model, you if you don't have the PMT editor, so the PMT editor can from Validas can do lots of things in compliance argumentation, document generation, and so on. And we also use this model to create our processes and do our compliance argumentation, and also our entire project process for the functional safety we develop on this process modeling tool. Very interesting use cases to mention. We are also currently developing a interface that you are able to export this this model into doors. So so you then could make use of the NLX tool to convert functional safety documents, technical documents, any type of requirements that are written down in Word documents or any other textual documents, that you could easily import them without much effort and much hassle into Doors Next. This interface is almost finished, and we would offer first an importer that uses the PMT model as a source, and then imports the content into Doors Next. But in the near future, this will go right away from the NLX tool directly into Doors Next. This interface has to be created, but we are working on it, and will update you with this news soon. In any interest, just feel free, do not hesitate to contact me on my internet address, my email address at validas.de. Oops. So this is my email address. Funny thing to note, NLX tool is also capable to do mail addresses, so it can parse this as an additional email object with all the features. Right, back to the process modeling tool. All right, back to the process modeling tool. This is what you can create out of this model. And as I mentioned, those next use case is one of our first really commercial use case that is almost ready for shipment. And yeah. All right, let's continue with the model itself. So this is the model. So it's passing through the document, and it discovers that there are cross references in the content found to other chapters. So when I just click on one cross reference and then I click on this button, I'll jump over to this cross reference of this requirement. And when I open up the extended section, then I receive the content of this paragraph section that is turned for me into a requirement. And thereby I can list. So here I see that this parser has also found sub-entries from a list, and he is extracting these parts into a sub-object, a sub-requirement that is then containing that list entry. And so it goes further into the document. So you have all the content listed, and also when I go into tables, for instance here, I receive a lot of cross references that this refers to. So the formattation is now a bit broken, but usually parser is capable to give a proper representation of the table that it is from the model itself rebuilt into the original status. Requirement document unresolved dependency just means that it found a certain number, like an ID or something like that, in the text that is has no real relation to another chapter. So if there is no chapter number with that content it found, then it will leave this unresolved. Just in case you require to use this anyway, I refrained to not remove those unresolved dependencies, but left it for any development purposes, because you then finally can easily remove these unresolved dependencies afterwards. Anyway, so better. I thought it's better to leave them in instead of yeah, removing them, and then finally you require them and are no longer capable to access to it. So this is, well, up to you if you want to leave those unresolved dependencies that just found IDs and numbers that have no counterpart in the document itself. So all these IDs that are found inside the document are just left inside as unresolved dependency at the moment. We'll see how this program develops further. That it also it's also intended in future versions that this tool is capable to link references across documents. So if the document refers to another document, then it will also create links to that other document. Right. This is the current working use cases as I laid out for future applications. Is that we will put a semantic parser on top that is capable to interpret the content of this document, and this is something that is currently under development and works as a tool that is, or as also proof of a hypothesis that you can do machine learning on models. And finally, train grammar on the document, and also then finally can resolve the content, semantic content of the document itself, and put it in a functional correlation, functional constraints to really process then the real content of the or the real meaning, so interpret the real meaning of the natural language into functional commands on the machine. All right, thank you for watching this demonstration of a natural language tool, and stay tuned for further development process that will be frequently posted on this channel. All right, not to forget, you can download this tool when you are going into the tool catalog, and then there is a standalone software available on GitHub. So the software itself is published on GitHub, and then you can download this tool on GitHub. So it's downloads here. So oops. One second. So here, somehow the link is broken. Here you find the real link to the prototype, and you can download this prototype here under this download link. I don't know why this was not working. Maybe there was this tag. All right, thank you for watching, and stay tuned for further the further progress of this tool. Thank you.